Hello everyone, I'm Luke Jordan. Today I will be showing you my related rate problem. A tank of water in the shape of a cone is leaking water at a constant rate of 2 feet cubed per hour. The base radius of the tank is 5 feet and the height of the tank is 14 feet. At what rate is the depth of the water in the tank changing when the depth of the water is 6 feet? So the first thing we're going to do is draw a diagram of our problem. The radius is 5. The height of the water is 6 feet. And the height overall is 14 feet. Water is coming out of the tank at a constant rate of 2 feet cubed per hour. And that is also equivalent to dV dt. The equation for volume of a cone is V equals R squared H pi over 3. The next thing we have to do is find a ratio between the radius of the circle and the height of the triangle. So you will see that 5 over 14 is the same as triangle for a height of 6. So using cross-multiplying and division, we'll find that the related rate of R to H is R equals 5/14 H. And that will come in handy right now. We plug in R so that we're left with nothing but H, and we will end up with this equation. Now we want to combine all the like terms, so we'll multiply, and we'll end up with (25 over 196) H cubed pi dH dt. Not yet. Pi all over 3. Now we want to find the derivative of this. So dV dt equals 75 over 196 H squared pi dH dt all over times 1/3. Now we will cross out these to make an easier, smaller equation. We'll end up with dV dt equals 25 196 h squared pi dH dt. We already know what dV dt is. We know what h is. All we need to find is our unknown. So we plug in the numbers we know, which is a rate of 2 feet cubed per hour equals 25 196 h, and h is equivalent to 6 squared times pi dH dt. 6 has units of feet. Now we multiply out and we will find 25 196 times 36 feet squared pi dH dt is equivalent to 2 feet cubed per hour. We divide both sides by 25 196 times 36 feet squared pi. And now we have dH dt alone by itself on one side. So dH dt equals, and these units will cancel out, leaving feet per hour, which is the unit we desire. The end result will supply us with 0.1386 feet per hour. And now, for this whole time, I was making you believe that it was positive. However, the 2 feet per hour is actually negative. So you go all the way back up to the top, and because it's decreasing the amount of volume left, it is a negative number. So every calculation must be made so that the 2 is in fact negative. Now that all that is changed, the final rate is negative 0.1386 feet per hour.